Alright, so today we're going to be doing a little review with solving systems of linear equations by substitution. And I found this actually on the internet. They call it the Blob Method, so I'm going to try this out. For some of you, again, this should be a review piece for you. And some of you did a really awesome job with substitution already. If you did, then just take advantage of the review. Those of you that didn't quite grab hold of it, I'm going to try out the blob and see if that helps. So step one for substitution, find an equation that looks like this. You either have an x equals where x is all by itself, or you have a y equals. I really want to stress this part, the or part. It could be either one. Could be either one. If you don't see one, and we'll go into more detail with this today, if you don't see one, you'll have to solve one of the equations for x or y. So just because I ask you to solve a system using substitution, it doesn't mean that your equation is ready to go. Okay? The ones that are easiest with substitution, yeah, that equation's already ready for you. And those are going to be the ones where you're like, yeah, substitution's a great choice for this. Alright, so what I'm going to try with this one, for this refresher piece, it says circle everything after the equal sign, and we're going to call it the blob. Substitute the blob into the other equation for the variable it equals, then solve. Substitute your answer from step 3 back into the blob equation, solve for the other variable. Write our answer as an ordered pair. So let's try this out. You guys have the steps on your paper. I just have a couple examples that I want to do together with you, and then I want to give you guys some time to practice. And if you need to finish up your graphing sheet, you probably should have time for that today too. Alright, so let's take a look at number 1. The first step says find an equation that looks like we either have x equals or y equals. Do we already have that in number 1? Do we already have an x equals or a y equals? Yeah, we sure do. Second equation, right? Second equation looks awesome. So then we have circle everything after that equal sign. It does make a little blob. When I found this on the internet, I'm like, that's a pretty neat way of looking at it. I like it. That's going to be our blob. So step 2 says circle everything after the equal sign. That's going to be our blob. Substitute the blob into the other equation for the variable it equals. That's the part I need to stress to you. It equals x. So I need to put the blob in for the x. And I need to take the whole blob. Some of us were just trying to take the 16 and pop it in there. I need to take that whole blob. Because when I put, sorry guys. When I put that blob in for x, the x is no longer there. Now I have an expression that has a y. So now my equation has nothing but y's in it. How our system originally started, both equations had x's and y's. I can't solve an equation that has x's and y's unless I just guess and check. And guess and check could take a while. So by putting the blob into that first equation, now all I have are y's. And some of you, when you did this last week, you did a great job with picking up on substitution, what we just did here. That's the new part. We have substituted. That's the new idea. From here, we have to solve the equation. So from here, we have to recall, we need to distribute first. So we get 48 minus 12y, and then we still have plus 4y equals 8. So after you substitute in, now we're just down to one variable. Now we're just solving an equation. It's a multi-step equation, but it's just an equation we're solving. So the biggest probably mistake I saw last week with this was when people went to combine their like terms. It's great. We're remembering what like terms are. We know we can only combine the things that have y's and the things that don't have y's. We know that. But if you want to keep those things on the same side, negative 12y and 4y, they're on the same side. I keep their signs the same too. So this is going to be, the 48 is going to stay. This is negative 12 plus 4. I don't do any sign changes unless I want to move something to the complete other side of the equation. That's when I want to do that opposite piece. Move our positive 48 by subtracting it. Be careful, we're left with a negative 8y. We're going to have a negative 40. Divide by our negative 8 to finish. So I know for some of you are like, Miss Golly, geez, that substitution, that's really bugging me. But a lot of you out there, when you tried this last week, you understood the substitution part. You knew how to put what we're calling the blob into the other equation. That part was okay. It was the solving part. We were making some mistakes, maybe distributing, or when we combine like terms. In this case, we might have tried to add the 12y with 4 instead of a negative 12. So for some of us, the frustration with this wasn't because we didn't understand the idea with substitution. It was because we're making some small mistakes solving equations, so we weren't getting the right answer. Now yesterday when we graphed, we got to find an ordered pair. We got x and y right away, all in one shot. With substitution, we find the variables one at a time. So we have y equals 5. Now, I like what the steps on this sheet say. Step 4, substitute your answer from step 3 into the blob equation. Use the blob equation. It's going to be your easier choice every time. So the blob equation was x equals 16 minus 4y. I loved that idea. That's why when I saw that they named it something, I always circled it. I was drawing a bunch of circles when I was helping you guys last week. But now that they call it a blob, I love that. Use the blob equation. The one that you circled, put it into that one. That's always going to be your easier choice. I'm looking for x, and x is by itself already. So we have 4 times 5. X equals 16 minus 20. Our x is negative 4. The best part about these, you can still check them. So I'm going to go ahead and write the ordered pair up here. I have x is negative 4 and y is 5. If you want to relabel x and y, you can. Don't forget to check. So into my top equation, 3 times negative 4 plus 4 times 5, do we get 8? Negative 12 plus 20. And I know for some of you, you shy away from the checks because you're like, Miss Golly, that check just looks like a lot of work. I'm probably right. I'm confident. I hope you are confident in your solving, because we're solving equations like rock stars last trimester. So even if you just put this piece in your calculator, parentheses and all, make sure it equals 8. I don't expect you to write out 20 steps to check. That's okay. Second equation is x equals 16 minus 4 times y. Negative 4 equals 16 minus 20. Yes, it does. It checks in both. It checks in both. And again, that can just be a quick calculator check. Throw this side into your calculator, make sure it equals negative 4. Parentheses and all, type it in just as you see it. Okay? Now, example number 1 is the type that I saw on progress checks, assignments, and quizzes for 5-2, we got for the most part. That's the kind that was looking good, the kind that was ready to substitute. Now in number 2 though, our step 1 says look for an equation that has x equals or y equals. I don't have that ready to go in number 2, so we have to make it. The easiest variables to solve for, to aka get by themselves, are ones that have coefficients of 1 or negative 1. So as I look at number 2, either of these two would be easiest to get by themselves. If I have just a plain old x, if I look at that first equation and I have a plain old x, I don't have to worry about dividing by anything to get x by itself. If I try to get x by itself in the second equation, at some point I have to divide by 4 to get rid of that 4. If I divide everything by 4, I'm going to get some ugly fractions. So if you're trying to figure out, Miss Golly, I don't have an x or y equals, which one should I try to solve for? Pick one that has a coefficient of 1 or negative 1. In this case, we have two different choices. So when you look at this, you really do, you get your pick. Neither way is really easier than the other. You get your pick. So I'm going to take the top equation, x minus 6y equals negative 7. I'm going to take the top equation and I'm going to get that x, that plain old x, all by itself. Either choice would be fine, guys. X or y. Doesn't matter. Alright, so if I have x minus 6y equals negative 7, and I want to get x by itself, how do I take negative 6y or minus 6y and move it to the other side? What do I do? How do I undo subtracting? You add, yeah. To undo subtraction, we add. Negative 6, positive 6, those are going to simplify. I'm left with just an x over on the left. Now the right-hand side, we don't need any special order, guys. We're not trying to like get some kind of slope-intercept form or something. We're not trying to graph. We just want x by itself. So don't try to move things around on the right side. It's a negative 7 plus 6y. I can't put the negative 7 and 6 together because they are not like terms. They don't both have y's. Alright, so it's time for our blob. It's time for our blob. Oh, it didn't switch colors for me. Let's try that again. Red. There we go. It's time for our blob. This is our first equation, if you need to label that. We need to put the blob into the other equation. It's an x equals, so we put it. Now this question is just like number 1. I've got x by itself, and I substitute in. So take a little pause here. Try it out. Try substituting it in. Try distributing. Try finishing solving it. I'm gonna work through the steps up here just so you can check yourself as you go. So you try it out on yours. If you have a question, let me know. I can come right to you and I can help you figure it out on yours. Again, I'm putting my steps up here so you can check yours piece by piece as you go. I don't expect you're as far as me on the solving piece, but I have each step up here. So if for some reason your answer isn't matching mine, see if you can do a little error analysis and figure out if your answer matches mine. Don't just take for granted I'm right. If you're finished already, make sure you check. When you guys take your test next week, you should be able to check every single problem and know you're right before you hand it in to me. Alright guys, here we go. Number 3 then. Looks like we all got number 2 under control. In number 3, we don't have an x equals or a y equals. And I wanted to make sure I went through a couple with you that didn't start with an x or y equals like number 1. Because for most of you out there, you did this last week, and when you had a situation like number 1, you were fine with substitution. You did great. So I wanted to make sure I hit a couple examples that didn't start like number 1, where we already had an x or y equals. So as we look at number 3, what's going to be the easy choice to get by itself? Which variable is going to be the easy choice? The y we're at. All right, so this y is going to be the easy choice to get by itself because it just has a -1 in front of it. So the -y in that top equation is going to be the easy choice because really there's just a -1 in front of it. Dividing by -1, that's never going to create ugly fractions for me, so that's going to be the best choice we have. If I try to get the x by itself that has a 2 or a 6 in front of it, I have to divide by 2 or 6. That's going to make ugly fractions for us. So I'm going to take the top equation. We have 2x minus y equals negative. Whoa, hang on. This thing isn't cooperating today here. Hang on. All right, so we have, all right, so 2x minus y equals -5. If it helps you to put the -1 in front of that y, that's fine. I've seen a lot of you do that. All right, so we got to get y by itself. So that 2x, I have to take that 2x, the whole thing, pick it up, and I've got to move it to the other side. How am I going to take positive 2x, pick up the whole thing, and move it to the other side? Subtract it, yeah. Subtract it. And some are like, yeah, Miss Golly, I already started number 3. That's exactly what I did. Positive 2, -2. Those x's on the left. See you later. But what we have to be careful of, we still have a -y on the left. Over on the right, again, don't try to get fancy. Don't try to put things in any special order. Leave them as is. It's a -5. It's a -2x. Leave them there. Don't move them. But now, y is still not by itself. I still have a -1 in front of it. When the -1 is right next to the y, that means we're multiplying those. So how do we undo multiplying? Divide. Now we have to make sure we divide everything by -1. The reason why I say dividing by -1 is the easy choice is because all dividing by -1 does is change all the signs. So instead of a -y, I have a positive y. Instead of a -5, I have a positive 5. Instead of a -2x, I have a positive 2x. So it just changes the signs. I don't get any ugly fractions to deal with. Make our blob. This is our first equation. So the blob has to go into the second equation, and I have to pay attention that it goes for y. The last 2 examples, we did x, we did x. Now we have to make sure we're paying attention. It's not x this time. It's not x this time. It's going in for y. So we have 6x minus 2, 5 plus 2x equals 2. So the only thing I've changed in the second equation is instead of y, I put our blob expression in there. I put the blob expression in there. I chose this example for 2 specific reasons. Reason number 1, we had to get a -y by itself, so we had to divide by -1. The other reason I chose this example is because when you go to distribute, this is a -2. That was something that I saw trip up a lot of people last week. And this idea of distributing -2, that's not a new idea because we're using substitution and we have a system of equations. That's how it's always been. So go ahead and try to finish off solving.
Did you say it right?
Oh yeah. Oh.
Not tobacco. Tobacco, but anyway.
Again, my steps are up there for 3 just so you can check as you go. Once you think you have that under control, let me know if you're ready, and I'll move you on to our activity.